the way you can scale up, scale down in production is known as HPA.YAML. The scaling in the Kubernetes, we call it as two types of scaling. HPA is nothing, it is a horizontal pod autoscaler, which will scale the replicas. And there is another scaling known as a vertical pod autoscalers. Okay. There is a way where we scale the horizontally, like we follow the HPA, and there is a way to follow the VPA. Most of the time we use HPA only. Let's first see what is HPA. The API version we call it as a auto scaling. We define the kind as a horizontal pod auto scaler, and we'll define the name. Now you have to scale what to what you have to scale, right? So for that, what you do, you write a scale target reference. You give the scale target reference, and this scale target reference you define that you want to scale the API version app v1, and you say that you want to scale deployment, right? You will scale what? You can scale deployment. You can't scale pods directly. You can scale deployment directly. So you will see that what deployment you have to scale. You must be having 100 deployment running in, right? So you give the name of the deployment. You give the name of the deployment. What is the minimum replica I need? I need two replicas. Right now I have three pods running, but here I need two replica minimum, and I need max replica 6. When it should scale up, okay, minimum 2. I understand that it will always be minimum 2, but on what grounds, on what things it should scale up? So it should scale up when my resource utilization, when my CPU utilization is crossing 70%. Okay, when it is crossing 70%, then you scale this up from the pod 2 to 6, or to 3 to 4 to 5, whatever the desired number of the pods are needed for this. Let's apply this kubectl apply -f hpa.yaml minus n sachin hyphen ns. And now you see, as soon as I have applied this, okay, now there is a problem here is that we are controlling this via the minimum number of replicas as 2. Okay, so we have applied this HPA. This HPA will be visible under the here storage, no, under the config. So you see under here it will be there, and it's showing that whether it is able to scale up or scale down or not. So it says this is the status, scaling active, minimum pods 2, maximum 3, 6, but replicas it is maintaining 3, because replicas are coming from where? From deployment. This is your reference. Okay. Current resource utilization is 1%. Target is 70%. So it will not do anything here, right? It will not do anything. Now to do ensure this, we have to do what we can. We have to just give me a minute. Sorry, guys. So yes, so now when we see here that when we applied that HPA, right? When we applied that HPA, but my deployment also had what? My deployment also had a replica, right? This had a replica which was not allowing it to control in a right way, right? Which was not allowing it to work in a right way. So what I'm going to do here is I'm going to delete my replicas from here. Okay, I will be deleting my replicas from here, and I'll update the deployment so that it is controlled by the HPA only. Okay, so that it should control by HPA, but it has not reflected. Let me do one thing. Let me delete this deployment. And here in the deployment.yaml, okay, I will delete this replica, because right now what is happening that this replica, okay, it is trying to do to 2, right? But my deployment replica is controlling that. Okay, that is controlling it. So I will do what? I will run this, and you see now we ideally You see, two pods are coming. We don't have any deployment defined, right? But this replica came in automatically via HPA. Okay, this deployment came in via the HPA, and my two pods are up and running here. Okay, so this is how you control. This is how you put up. This is how you add up the things with respect to the HPA. Okay, if you increase your HPA scaling to 4, it will have a 4 pods minimum. So now if you see here, the deployment events, if you will see, it says scaled up replica from 0 to 1, scaled up replica from 1 to 2. Means it will tell you the scaling has happened or not, right? If you will see the pods here, right, you see based on the utilization, it is scaling up and scaling down, right? Right now my CPU utilization is more, it is automatically it has scaled up to 3. Now you see this pod. Okay, this has nothing. But if you see back scaling events of a deployment, it's saying scaling up replica from 2 to 3, scaling down replica from 3 to 2. Okay, and if you see HPA, so it's failed to get CPU utilization. So it was trying to do whatever the other things it can, right? Is it clear? Does it make sense, guys? So we saw, right, that the HPA, right, that is HPA is something which is always being controlled, which we have used the replica and the things here, right? It is always helpful or attach, or it works on a deployment and a replica set. Vertical pod scalers works on a pods. HPA is faster compared to vertical pod. HPA adds more number of pods. Vertical pod scaling add more number of resources. It changes your resource requests and limits. Not only that, but also the pod scaling, instead of only on CPU, you can do it on memory, you can do it on custom metrics like Prometheus adapters or Prometheus exporters. You can do it on KDA based, event based scaling. Okay, now the any of the stateless workloads, anywhere the microservices, APIs, and all those places, you use HPA only. VPA is less used and it's not recommended. Again, I would not say that it's not recommended, so sorry about that, but mostly yes, it is used. We use it on ML models, we use it on batch jobs, databases, and these kind of concepts. Apart from that, the to install the VPA, you can't install VPA directly. Okay, you have your, because the CRDs, the custom resource definitions, is one of the again concept which we will see later. But there are the lot of the CRDs, like this, are available in the Kubernetes by default. And the the custom, these CRDs are not available for us directly. So how does that work is that for VPA we have to install these CRDs. So you have to use some of the commands, which like provides the us to install the VPA. So we use this, the kubectl autoscaler CRD and the normal CRD, and you install those CRDs. We will not see that in this thing. So these CRDs will basically install your VPA admission controllers, VPA updaters, recommenders, and then it runs the pod and things. And then you basically run the deployments and other things, and you can create a VPA resource to update that. So that is how the VPA and the things works in. So it is not directly supported. You have to install the CRDs and the things to have a VPN, those things.